Hello problem solvers. So here is a system of equation. It looks like, well, please have a go first before watching my comments or solution. So my first impression is that I can take away the square root of a by a substitution, but it looks like that's the only way to go. Somehow we need to remove the square root by squaring. So first of all, let's just do a quick substitution so that it becomes 2 plus x equals y squared. That's just my my habit. Okay, I feel that it's easier to have to eliminate the square root, and nothing we can do. We have to take away the square to move it to the right hand side, and we will have 2 plus x equals y squared minus 2 squared 2 plus y. Okay, so now what do we do? Not much I can think of, so I guess I'll just have to try to solve it. Usually, okay, substitution won't work. Substitution, if you do substitution, this is already degree 4. X equals degree 4 of y. If you put it here, the degree will be very big. So let's just subtract the equation. Let's say this is equation 1, this is equation 2. Let me try 1 minus 2. Then I'll have this minus this. Okay, and I will get 4x squared minus 4y squared plus, or let's say minus x4 minus y4. So obviously we can factor the x minus y factor. So if I take out the 4, I have x squared minus y squared. So that will give me this. And then this, you can factor it several times. So we can take away the x minus y factor. So if we assume x is not equal to y, so let's say we have two cases. So case 1, x equals y. Okay, then everything becomes 0, and I will have this equation 1 becomes this, which is unfortunately a degree 4 polynomial. Oops. This is plus 4 minus 2 is plus 2. So degree 4, not my favorite, but if you notice, well, whenever you are at this situation, you can only hope that one of the roots, at least one of the roots, is a easy root. Let's say an integer. Okay, and there is a theorem, rational root theorem, probably says that if you have a polynomial with integer coefficients, just like here, and you have a rational root, let's say the rational root is let's say u over v, then u, if you can imagine, if you substitute u here, u should divide 2 and v should divide this, the leading coefficient. So that means u must divide 2, v must divide 1. Okay, for u and v which are integers, that tells you v should be 1. Okay, but u can be plus or minus 1, plus or minus 2. Okay, so if x has a rational root, it has to be these. It has to be these. That is what the rational root theorem tells us. And luckily, if you just look at the system, you can just find, you can just by trial, you can see that if a is 4, if a is 4 and b is 4, and there is a solution, that means x equals 2 is a solution. So we can do long division to simplify this. Okay, so if you do long division, I have a root which is 2. Okay, so I have factor out a root 2. Okay, and you can just keep on wishing, hoping for the best, that one of these, I just tested out 2, right? 2 is a 2, turns out it's a root. What about 1 or -1, -2? -2 doesn't work. -1 works. -1 works, and 1 doesn't work. So we have that's just the long division. Okay. Oops, forgot my +1 root. That's what I found, right? I found -1 is a root. So yeah, obviously this has some irrational roots. Okay, so in this case, in case 1, we have found 4 roots. But please remember that we did several squaring, and so maybe some of them are extraneous roots. So we have to test it out later. Okay, but for now, let's just keep it there. Okay, so let's say x is 2, -1, -1. So just use quadratic on this quadratic formula. So obviously my x is a square root, so this is not okay. This is not okay because these are negative. Okay. Yeah, this is fine. This is fine. So those are the 2 roots in this case. In case 1, x equals y. We still have the second case, which we have to cross out these. So let's try the case 2. X is not y. Then we can cancel this factor everywhere, and this equation becomes 4x plus y minus x plus y x squared plus y squared. Okay. Let's just factor x plus y first. Okay. Since this is at least cubic, right? This case looks difficult. Okay, let's wish it has no roots. Somehow we can prove that there's no solution, and indeed we can. Okay, it turns out, you see, this is 4 minus x squared minus y squared, and if you look at here, if you add these two, you have x squared plus y squared minus 4, right? And the left hand side is positive or non-negative. So x squared plus y squared minus 4 should be non-negative. But here, and x and y should be non-negative. But here, this is non-positive. Non-positive times non-negative is positive. Let's just say that is not possible. Okay, so let me write down my argument. So if you add these two equations, if you add these up, right, you can see that the claim is that there's no solution in case 2. Okay, because if we add these, we get x squared plus y squared minus 4, but this is non-negative. Okay, and my x and y are also non-negative. But here, in this equation star, okay, I have let's just say okay, this is, because this is non-negative, this is non-positive, this is non-negative. Okay, so the end result should be non-positive, but the left hand side is positive. Okay, so contradiction. Okay, so no solution. Well, I want A, right? So the solution of A, B, which is x is squared and y squared. X is, in case 1, x equals y, right? In case 1, x equals y, x is 2, so y is 2, so A and B are 4. And what about this one? Let's see. We haven't I didn't test it out, but you can actually, let's do a quick test now. So square root of 5 is 2.2 something, right? Minus 1, 1.2 divided by 2. So this is the golden ratio, 6.2, 6.18 something. So if x is that, A, let's just substitute here. So 2.6 square root is 1.6 something. Okay. Y square, this is 0.6 something. Square is even smaller, 0.3, 0.37 or 38. Minus 2 is negative. That's not possible. So this is not possible as well. So actually that is the only solution. Okay. This is well, this is a technical question. It's not, well, the first part is not that hard. Okay, this is just textbook knowledge, but this part, it requires you to notice that there is actually no solution just from here. Okay, so that case, that was well, that was lucky. It turns out there is no solution. Otherwise, this is that would be quite hard to solve. Okay, so let's give it a difficulty score. So it's definitely not that straightforward, so I'll say about 3 out of 9, and the character is 10/10. Not easy to beat. Okay, thank you for watching. Rational theorem, okay. Rational root theorem, probably. Rational theorem, okay. Rational root theorem, probably.